The original Raspberry Pi was a $35 experiment designed to bring basic coding into classrooms. Since then, the platform has transitioned from a simple learning tool into a versatile hardware tier used for complex home infrastructure. These boards are now capable of managing every sensor in a smart home, serving high-definition media, or even running specialized artificial intelligence agents locally. But that capability creates a specific choice. You have to decide if the financial savings of building a custom system are worth the time you'll spend troubleshooting, or if you should pay more for a commercial hub that works immediately. We are looking past the hobbyist hype to see how these boards actually perform. The goal is to match your specific technical needs to the exact hardware required, so you don't overspend on specs you won't use. This flowchart breaks the ecosystem into 3 paths: home automation and media, vision and cameras, and edge compute and AI. The first covers smart hubs, cloud storage, and environmental controls. The rest covers security, photography, and running large language models natively. Blindly buying the newest board without a clear goal usually leads to one of 2 outcomes: a wasted budget or a project that never makes it past the setup screen. The Raspberry Pi 5 is the current standard for projects that require a responsive interface. The hardware jump is most visible in active tasks, providing smooth 4K video playback and a desktop environment that feels snappy rather than sluggish. This chart compares memory performance across generations. While the Pi 4 maxes out around 6,000 megabytes per second, the Pi 5 reaches nearly 30,000, which is a 5-fold increase in how quickly the system can handle data. However, the Pi 5 runs much hotter, requiring an active cooling fan. It also draws 2.15 amps under load compared to the Pi 4's 1.3 amps, making it much harder to use for remote, battery-powered projects. If your project runs in the background, like a Home Assistant server or a private file drive, the older Pi 4 is often the better choice because it's more energy efficient. The Pi 4's primary weakness is interface lag. If you try to use it as a desktop replacement or an active media streamer, you will notice significant stuttering when loading web pages or 4K content. The Pi 5 is necessary for any project with a screen you'll actually interact with, while the Pi 4 remains the ideal choice for headless utility tasks. For vision projects, the hardware choice is between easy integration and professional-level optical control. This matrix highlights the trade-offs. The Module 3 offers rapid autofocus and HDR, but its fixed lens and small sensor struggle in low light. Conversely, the HQ camera uses a 52% larger sensor, delivering cleaner images critical for detailed photography. However, the HQ camera has no native autofocus and does not include a lens. You have to buy separate C-mount lenses, which significantly increases the total price of the setup. Stick with the Module 3 for security or basic monitoring. Step up to the HQ camera if your project requires specialized lenses for things like astrophotography. The most extreme use case right now is running large language models natively on the Pi's hardware. This setup lets you host a completely private, offline AI agent. You avoid API fees, and your personal data never leaves your local network. The reality of this edge computing is significant latency. Generating a response to even a simple prompt can take several minutes on this hardware. You also face software instability. Models are pushed to their limits, getting stuck in logic loops or hallucinating incorrect code. While it's an impressive proof of concept for a $50 computer, local AI on a Pi requires extreme patience and isn't yet a reliable replacement for cloud-based assistance. This quadrant chart maps the hardware to your level of technical effort and required capability. First, the tech-curious beginner. The ideal setup here is a Raspberry Pi 4 running a smart home hub or media player. This avoids recurring subscription fees for commercial hubs, though you have to accept the learning curve of flashing SD cards and manual configuration. Next is the Home Lab Optimizer. This user should choose the Raspberry Pi 5 combined with an active cooling case. By managing the thermal load, the hardware maintains the speed necessary for multi-tab web browsing and snappy application launches. Finally, we have the Specialized Maker. This tier is about matching custom peripherals to niche goals, like using the HQ camera for vision projects or testing the slow, experimental world of local AI. Keep in mind that as you add more capability, the physical setup becomes much more complex. A fully deployed system often ends up as a dense tangle of power, Ethernet, and camera cables. The Raspberry Pi ecosystem rewards specific goals. Define exactly what you want to build, buy only the hardware that fits that path, and then start tinkering.